Hello, this is Mahan Didia. The book on liquid formulation utilizes qubit video format, and this is an on-demand dynamic supplemental book. In this book, we have used integrated approach used by innovative pharmaceutical and cosmetic institutions. Starts from pre-formulation, formulation and composition, manufacturing equipment and processes, and finally quality and clinical study formulations. Each of these modules contains sub-module related videos. It starts from preformulation, solid properties and Zeta potential, sedimentation, and then formulation composition, compositions of vehicle and surfactants, auxiliary agents and rheology modifiers, and finally some examples of formulations and their composition. We follow with manufacturing equipment and process, equipment first, hydration of solids, and homogenization. Then we look at laboratory scale formula and processes, followed by commercial scale formula and processes. Finally, in the module 12, we cover quality by design and stability study designs. And finally, we look at formulation used in clinical studies, their dissolution, and bioavailability. Preformulation is important in suspension formulations. In this submodule, there are two related videos: solid properties and Zeta potential, and sedimentation. Readers are requested to refer to Module 3.1, Physicochemical Characterization, for information on insolubility and Zeta potential, and also look at Module 5, Preformulation Solution Formulation. A dispersion of finely divided insoluble particles, disperse phase in a fluid vehicle, also known as dispersion medium. The vehicle is considered a single phase. It is a solution or an emulsion. And in this related modules, we will look at solid particles. We have discussed single phase characteristics of vehicle and its preformulation in earlier modules. Reason for suspension preparations include poor aqueous solubility of drug, sustained release of the drug that is not provided by the solution, efficacy, and stability. There are several types of suspension used in pharmaceutical and cosmetic products. Examples are ophthalmic suspension, oral sustained release suspension, otic suspension, parenteral suspensions, and vaccines are very common. Topical suspensions, dermatological preparation, and cosmetic suspension. So let's focus on pre-formulation study of. Pre-formulation studies are performed in laboratory, and the main goal is to generate physicochemical information on solid phase and vehicle phase for developing stable, clinically effective suspension dosage form. This information then is used by formulation scientists. This particular module will focus more on solid phase and pre-formulation studies to characterize solid phase. Suspension is a biphasic, insoluble solid phase, and a vehicle phase. For pharmaceutical organoleptic properties, because suspensions contain solid, palatability of grittiness, vehicle mediate, and we'll look at how studies are done to characterize that. Assay development is important. Solid state characterization, particle size, surface area, surface charge on particle for stabilization. Although the solids are insoluble in the vehicle, they're soluble in body fluids. Similarly, ophthalmic suspensions, we need to look at the solids, dissolution, and bioavailability. Stability analysis includes solid state stability. Suspension stability and drug excipient compatibility was looked in earlier module 5. Preformulation studies palatability for pharmaceutical use and skin sensory analysis for cosmetic. The pharmaceutical preparation has poor palatability. It may lead to non-compliance. There are many reasons for poor taste, particle size of solid, oral grittiness, rough mouthfeel, and that is due to the presence of particles in the mouth. Vehicle viscosity. Vehicles are used to stabilize suspension. If not properly formulated, it will unpleasant mouthfeel. Palatability is one of the criteria for quality by design, QBD. Cosmetic suspension. Solids are included in many emulsion formulation, follow sensory characterization. For example, mica, titanium dioxide, they provide gloss, covering, or whitening on the skin. Larger the range of particle, more easily they even out on skin. In addition to that, when particles are large, there's a roll-on effect. Palatability study that was done using salads. Different particle size simulate particle size. Suspension is sweetened with orange flavored HPMC. HPMC concentration is increased in a preformulation studies. Particle size, in this case 90, 127, 263, is shown here. Amount of particle from 0.25, 0.5 to 1%. So we can look at three variables and see of the particle size, HPMC, viscosity enhancer, and the amount of particle will provide acceptable result. In this study, 30 young adults aged 20 to 25 were involved. It's a single blind study. Samples are evaluated by swirl and spit technology, which is common EMA requirement. 10 ml of the suspension is placed, is moved around for 15 seconds before spitting it out. Immediately, information is collected using questionnaire and visual analog scale. Subject facial reactions from very smooth to very gritty. The results are shown here. So we look at the viscosity and the shear rate, and the HPMC concentration increases, viscosity increases, and as shear rates is increased, if we are swirling it, we are increasing shear rate. So this information helps scientists decide what kind of concentrations of the viscosity enhancers will be acceptable from the palatability. Particulate salads, which are round, different particle size as shown before, particle size and amount of particle and grittiness scores are graphed. This information tells the formulation scientist that VAS score here in this range where particle sizes and amount of particles gives it's not gritty or it's smooth. Whereas larger particle size and larger amount of particles gives VAS, that means it's gritty. Information then is looked at it from VAS score, goes from 0 to 100, amount of from 0.25, zero point 0.5, and 1, HPMC, hydroxypropyl methyl cellulose concentration from 0.5, 1 to 2 is shown here, and particle size are shown here. Based on this type of graph, this is acceptable grittiness score less than 20, less than 20, less than 20. This type of information, one can start deciding what are the factors that are in palatable formulation. Solid characteristics, particle size, and particle charge and zeta potentials are important. Reader is requested to refer to module 3.1 physicochemical characterization for more information on zeta potential. So each of the particles that are suspended carry a charge. In this case, a negative charge is shown. So surface charge is negative. That depends on the charge in the vehicle. And if it's an aqueous vehicle with electrolyte, it will have a positive charge and will bring the negative charge on the surface. Negative charge on the particle starts attracting, positive charge starts attracting, and there's a layer slipping plane. Beyond that point, positive charge is not attracted towards the particle. This is zeta potential. Zeta potential is critical in determining suspension characteristics. Measure zeta potential of the particles, prepare a known sample, test sample. The instrument, there's a special cell that's used for measuring suspension. Zeta potential is shown here. Colloids, nanoparticles, proteins, etc. We can measure its zeta potential. And there are many instruments available. We insert the samples in a specialized cuvette and then measure the zeta potential. Graph by select parameters. So here's an example of a zeta potential or intensity RST. So magnitude of zeta potential is an indication of suspendability behavior of solids in suspension. So zeta potential of around 5 and generally minus shows rapid coagulation or flocculation. Suspension will be flocculation suspension. As zeta potential increases to more than 30, it shows deflocculated suspension. In cosmetic industry, deflocculated suspension is commonly used. In pharmaceuticals, both flocculated suspension as well as deflocculated suspensions are used. Particle size, solubility, and bioavailability. Oral drug in a suspension is not soluble in the vehicle. That doesn't mean it's not soluble in GI tract. If the drugs are insoluble in aqueous system, then drugs generally have a high intestinal permeability. In preformulation studies, we look at different particle size and make suspensions and look at bioavailability in animal models such as dog. As particle size decreases from 5.49 micron to 0.12 micron, bioavailability increases. So fraction of a drug absorbed versus solubility and particle size are shown here. As solubility increases, fraction of a drug absorbed increases. As particle size increases, fraction of a drug decreases. Based on this information, scientists can then select the particle size that would provide appropriate bioavailability.